we're ready to get started. Thanks everybody for joining us on December 12th today for our monthly Kubecost Kube Chat. We're going to be talking with Mike Riggs today about Kubernetes efficiency, specifically how to balance pod performance with cost controls. Mike Riggs is a solution architect. I'm going to introduce him in a moment. We've got a good group here. We've got a small agenda that I'm going to take you through really quick. Quick housekeeping notes. There is a Q&A button at the bottom center of your screen, right, with a little question mark in a speech bubble. Use that if you've got some questions that you come across during the webinar. We're going to answer all questions at the end. Feel free to put any questions that you've got in there, and we'll answer them when we get to the end of the presentation. For everybody's benefit, we're going to be sending out a recording of this and the slideware that we used. It may take a day or two to show up in your inbox, but everybody that registered for the webinar is going to get a recording of this webinar. So don't worry about that one bit. Today, we're going to go through a quick introduction. We'll talk about efficiency and pod performance. If you're not aware of who Kubecost is, though, I'm going to do a quick introduction here. We are a real-time cost visibility and insight solution for teams that are using Kubernetes. So pretty specific for Kubernetes. We help you continuously reduce your cloud costs and improve your operational efficiency around using containerized applications. Kubecost runs on any Kubernetes environment, whether that's EKS, AKS, GKE, on-prem, weird stuff that you've come across. We can work with Kubernetes anywhere. We're currently managing more than $5 billion worth of cloud spend across all of our customers. We'd love for you to be a part of that and enjoy the benefits. We're a global company with teams all over the world, and we were recently acquired by IBM, so we are now IBM Kubecost and a part of the IBM FinOps suite. And we love that a lot of leading companies worldwide look to us to help them reduce their Kubernetes costs and optimize their operations. Companies like GitLab, EA Sports, Johnson & Johnson, Audi, Pfizer, and others. So if you haven't heard about Kubecost before, welcome, and be sure to check out our website, our blog, our endless Kubernetes resources that can help you do things better, faster, more cost effectively. And a little bit about Mike Riggs. Mike's a solution engineer here at Kubecost. He's spent more than the last 10 years working with Kubernetes and other cloud native technologies, and he would love it if you'd connect with him on LinkedIn, but not try and sell him anything. So, avoid that part. Mike, I'm turning it over to you. Please take it away.
Appreciate it. Thanks, Jeff. Hey, everyone. Appreciate everyone joining us today. So what we're going to talk about here a little bit is this is going to be kind of an overview of how do I provision Kubernetes workloads? How do I make sure they're not over-provisioned or under-provisioned? And then kind of part of that is also going to be, okay, I've got my stuff up and running. How do I make sure that they're efficient and that I'm not spending excess amounts of money in that public cloud environment? So there's a few steps to this. And we're going to kind of go through these. We're going to talk a little bit about some tooling. We're going to talk a little bit about some steps, kind of some basic kind of getting started type thing. And so the first thing you want to do is you want to establish a baseline for your application. Unless you want to live dangerously, this is typically best done in a staging or test environment. But if you're feeling bold, you do you. The other thing is what sort of tools do we want to look at for application monitoring? So there's a bunch of tools out there that are range from things like open source tool to commercial products, and Kubernetes itself has some tooling that's built in that can be used to kind of establish a baseline for your applications. So the first thing you want to do is kind of figure out what environment do I want to do this in, and again, staging test environment is probably your best bet. Open source tooling, I think probably the most common ones that we're going to see are going to be Prometheus and Grafana. And a lot of you probably already familiar with these, but I'm going to touch on these for folks that may be just kind of relatively new to all things Kubernetes. So Prometheus basically is a database that we use to collect and store usage metrics. And then also often kind of works in conjunction with Grafana for graphing that information. So these two are kind of typically seen together. And what we want to do there is we want to start pulling metrics and then graphing them using Grafana to kind of understand what resources my workloads are using. I want to kind of get that baseline sort of indication of how much resources does this workload need. And then there's another tool out there called Goldilocks. This is another open source tool. Goldilocks is kind of cool. It'll tell you before you go deploy a workload, it will give you kind of an idea. It'll help you identify a starting point for resource requests and limits. So I would encourage anyone that's not seen it to go give a look at Goldilocks. It's got some pretty neat little capabilities. Again, it's part of that open source tooling group. Kubernetes in and of itself has a couple of things built in that can also be used for that application monitoring. I think probably one of the probably most important ones is going to be the Kubernetes metric server, or KMS. And this is going to provide us CPU and memory usage for all of our pods and nodes, so we can see how much CPU, how much memory is being used for my workloads. Another kind of key Kubernetes component here is going to be cAdvisor. This is built into Kubelet, and it also is going to provide more of a detailed resource usage and performance data. So KMS is kind of going to give us some metrics, or some basic metrics, but cAdvisor is going to have a little more insight into what's going on since it works there with Kubelet. And then another tool as part of that Kubernetes area there is going to be the VPA, or the Vertical Pod Autoscaler. This is not installed by default, but it is part, as most standard Kubernetes installations don't include this, but it is an add-on component that you can go deploy. There's a piece of the VPA that's called recommender. So VPA's got 2 or 3 different components we're going to look at here in a minute. But the recommender component specifically for this use is good because it can look at history, if I've had out of memory events, and it can go look at that history of that app and then give you some fair, reasonable suggestions for what are reasonable requests. So that's kind of a lot of the stuff that's open source tooling, that's Kubernetes tooling. Those things are all out there and available. And then for organizations that already may have some commercial tooling in place, like Datadog, there are some other tools out there. Datadog and SpirePlan are kind of the 2 biggest ones that I'm aware of that folks use for that application monitoring to establish that baseline. So this is a look at some of those tools that you might start considering when you want to understand, what does my application need? So now I've chosen my tools that I want to work with. I've got my environment identified. Now, what do I want to monitor? So there are a bunch of things that you can monitor as far as Kubernetes workloads go. These are going to be some kind of basics. This is not a comprehensive list, but the kind of key ones that we typically see folks looking at are going to be things like CPU and memory utilization. If it's a GPU heavy workload, or if it's a workload that requires GPUs, we probably want to look at GPU utilization as well. And then there's a couple of other things that to kind of keep in mind, things like response times or error rates. So if I'm seeing an increase in response times, that's typically an indicator that workload may need additional additional resources. And same thing, if I'm seeing a lot of error rates if my application's throwing a lot of errors, that's also another indication that it may need additional resources. And then throughput. So if I have an application that is, kind of reliant on being able to push a lot of data quickly, and it's not, we're seeing some slowdowns in that application throughput, then that's another indication that, this is another thing I might want to monitor. Again, you might your application is going to have specific requirements based on the type of application it is. This is kind of more of just some broad kind of guidelines, kind of a starting point to establish that baseline. And then so what you want to do is, once you kind of identified those metrics, then you want to track and analyze those metrics over a period of time. And we typically suggest a week, maybe a little bit longer. That application is going to have some ebb and flow in terms of resources that it consumes. So you want to make sure you capture all of those highs and all of those lows. The other thing to kind of be aware of is Kubernetes clusters in general are not static. So as you add and remove workloads to those Kubernetes clusters, your resource requirements are going to change, and you may affect workloads that are already running in that cluster. So this is the sort of thing where I've got my kind of baseline established. I have a working knowledge of where I want to start looking at requests and limits, but this is going to change over time. So it's going to be more of an ongoing process where I want to reevaluate the needs for my applications on a fairly regular basis. But the kind of that first step you want to do is, I want to establish that baseline so I can have a starting point for the types of resources, the amounts of resources that I'm going to need. So real quick, before we kind of go a little further, This is probably basic information for most or all of you folks, but I do want to touch on it real quick, just so we kind of have cover the basics here. So when we talk about resource requests and limits, and that's kind of the core of what we're going to be talking about today, kind of baseline so we understand what we're talking about here. Within the specs for your workload, you can specify an amount of resources that workload needs. So I can specify how much memory do I want, how much CPU do I want. If my workload requires GPU, I can specify those things. These are requests. Requests are going to allocate resources. So when I go say this workload needs, in my example here is 64 megs of RAM and 250 millicores of CPU, that workload is going to request that. But if that workload is not consuming those resources are wasted. They're earmarked for that workload. But if that workload doesn't consume everything, that's going to be just wasted resources in your cluster. The flip side of that is going to be limits. So limits then allow me to specify here are the maximum amount of resources that a workload can consume within that cluster. So kind of two different sides of it. There's a little bit of a philosophical sort of thing. I think most teams implement requests. That's usually kind of best practices. Limits are a little bit more of a philosophical sort of question. There are entire applications out there, suites of applications that are designed to kind of alleviate the need to use limits, whereas other organizations, they're dead set on having to set limits on all their workloads. So again, kind of varies from organization to organization, but the basics here are when I go request resources, those resources get earmarked for my workload. And if the workload doesn't use them, those resources get wasted. Okay. So now we want to start looking at resource optimization. So we've kind of established a baseline. We know what resources our workloads need. We know how much memory, CPU, maybe GPU these things need. So now we want to start looking at, I want to optimize these resources. Typically what you're going to see is your different environments are going to have different requirements. So usually in a dev, test, or staging type of environment, in these environments, we often see customers running their workloads at about 80 to 85% of CPU and memory consumption for those workloads. So you can kind of think of that as leaving about 15% resource overhead, 15 to 20% resource overhead in that cluster. Whereas in production, you're typically going to want to be a little bit more conservative with that. So I want to leave, more of a maybe 35, 40% resource overhead in a production environment. So again, kind of keep these things in mind when you're going to specify those requests for your workloads. Different environments are going to require different types of requests. Another thing we can look at in terms of resource optimization is utilizing that VPA that we talked about a minute ago. It has a couple of different features that are very useful for this type of application. So the VPA can automatically adjust resources or resource requests based on historical usage patterns. And then you can also specify within the VPA, there is a min allowed and a max allowed resource container policy. So you can say for this workload, here is the minimum amount of resources needed. Here's the maximum amount of resources that are needed. VPA, so the part that we're looking at using there is VPA comes in three kind of main components: the recommender, the updater, and the admission controller. What we're looking at for here is going to be that recommender. So the recommender is going to be monitoring that historical resource consumption. It's going to look at metrics history. If there's been any out of memory or CPU eviction events, that's going to base what it recommends on those types of things. So it's looking at more historical data than anything else. We also want to look at node affinity or anti-affinity. And there's a couple of reasons you might want to do this. So node affinity is really good for resources that have very specific requirements. So for example, if I have a workload that requires GPU, I can make sure that I use node affinity to make sure that workload runs on a GPU node. Or maybe I have performance requirements. So I want to make sure that workload runs on a node that's using, say, for example, SSD for storage, if I need that storage throughput. The other thing that you can kind of think about here is if you have two like microservices, for example, that work together, oftentimes it's not a bad idea to schedule those workloads on common nodes. Since they work together, makes resource allocation a little easier. The flip side of that is node anti-affinity. And so what anti-affinity does is it's going to spread your pods across nodes. So for example, if I have, say, for example, 5 replicas of a database application, I probably don't want all of those running on the same node. So I want to spread those across nodes, and this is going to not only improve my fault tolerance, but it's also going to make sure that application has the resources it needs across that node spread. It also gives that application an additional layer of high availability. So node affinity, anti-affinity, these are good things. The last couple of things we want to kind of point out here, labels. Labels are absolutely just so important to making sure that things are happy in your Kubernetes environment. A lot of the stuff that Kubecost looks at when we're looking at being able to group up costs together, a lot of it's label based. Labeling things makes it easier to do stuff like group my resource together. So if I want to understand what resources are being consumed by a team, by an application, or by a project, I can label those resources with that team, application, or project label, and allows me to group those resources together to make it easier to track those costs. It can also give you insight into resource usage. Again, and the idea of I can kind of use that label as a handle to grab all these resources and put them together, so I can understand what sort of resources those are consuming. It also makes easier. It makes it to it makes it easier to maintain consistency across deployments if you have good labeling hygiene. It's one of those best practices things. Labeling stuff makes your life so much easier. One more, or a couple more ways we can look at optimizing those resources. We can look at autoscalers. So your public clouds typically have some sort of autoscaler mechanism built in. GCP offers autopilot. Carpenter is in AWS. Other public clouds, Oracle has OKE, for example. So most of your public clouds are going to offer some sort of an autoscaler that can then scale those clusters up and down based on the requirements for those workloads. And then the last kind of thing is set requests and then limits if you need to. Once you've got a baseline, you probably want to start kind of conservatively. So I've got my baseline. I'm going to go pretty conservative with those requests. I want to make sure that I'm kind of keeping in mind those environmental needs. So if I'm a production environment, I probably want to make sure that that request is going to be a little more conservative to leave that additional overhead in those clusters. Where again, in a dev environment, I can probably request a little bit more resources with the idea that I don't need quite as much overhead in that type of environment. So start kind of conservatively, but also kind of keep in mind the environment that you're optimizing those resources for. Okay, so now we've kind of looked a little bit about how can I optimize my resources. How can I then start looking at costs? So it's two sort of separate activities, if you will. So let's look at some cost optimization guidelines. Now, some of the things that we've already talked about when we're talking about resource optimization, some of those things are going to carry over into cost optimizations. So some of this is stuff that we've already kind of touched on, but we're going to kind of go into a little more detail here over the next slide or two. So spot instances. Spot instances are a great way to optimize cost. Not every workload will tolerate spot instances. So things to consider when you're looking at spot instances: does my workload require things like local storage? Is that workload part of a controlled workload, like is it part of a deployment, a replica set, a stateful set? If it's just a naked pod out there by itself, probably not a good idea for spot instances on those. And do I need a number, or does my workload have a minimum number of replicas? So the idea there is make sure that your workload will tolerate it. If nodes get removed from your environment, there are some factors to kind of keep in mind there to make sure that workload is happy if a node gets removed. One of the things we've already talked about is I want to optimize my node selections for workload requirements. And again, it's back to the idea of those being able to label those resources. So if I have workloads that are particularly CPU, GPU, or memory intensive, for example, I want to put those workloads on nodes that are specifically optimized for CPU loads, GPU workloads, or memory intensive workloads. It alleviates the need to go scale up to a bigger instance to make sure you've got enough memory, for example, when I can just use a smaller instance, but most of your cloud providers are going to offer, a memory, a memory optimized instance, CPU optimized instance. So the idea is make sure that your workloads are placed on those instances that are optimized for those types of workloads. We talked a little bit about some of those autoscalers that are available in some of those public clouds. There is another tool that's built into the Kubernetes toolkit. That's going to be the horizontal pod autoscaler. So difference here is the horizontal pod autoscaler is going to scale horizontally. So we're going to adjust the number of pod replicas. Difference there is the VPA is going to adjust CPU and memory resources allocated. So a little bit different sort of mechanism there, but I can use that HPA to scale out the number of pods of replicas in my environment based on demand for that application or that service. Node affinity, again, we've talked about this. This again goes back to the idea of making sure that my workloads are placed on workloads that are optimal for those types of workloads. Storage is another big one. And we're going to look at this here in a second when we take a look at the demo, but we see oftentimes storage gets provisioned in these big blocks. And oftentimes they're very over provisioned, not only in terms of size, but in terms of what does my application need. So for example, most of your cloud vendors are going to offer different storage tiers. So I may have a lower cost, lower performance storage tier. If my workload can tolerate that, that's probably a pretty good option in terms of saving some cost. So again, what my application needs, I want to choose my storage type based on those application needs. We can use things like data lifecycle policies, deduplication, compression. And so data lifecycle policy we can use to evict data that's over a certain age, again, kind of reducing that storage cost. And then we can use things like deduplication and compression to reduce the amount of storage that's necessary. There's also tools built in like namespace quotas. So namespace quotas allow you to set a hard limit on the total amount of resources like CPU and memory and API resources consumed by all pods in a given namespace. So if I put a quota on my namespace, I'm going to restrict the resources that can be consumed in that namespace down to whatever amounts that I specify for that. So it's more of a bulk sort of a quota versus individual apps or containers. So namespace quotas will let me apply that quota to a larger grouping of resources like a namespace. One thing that's kind of interesting that I think that I really personally was not really aware of in a lot of detail until fairly recently is network transfer. And this is something that's come up. As kind of in the course of working with customers over time, we can identify network traffic in terms of, is this cross zone, cross region? And working with a couple of customers, they realized that if we redesign our Kubernetes topology to minimize those cross region or cross availability communications between my Kubernetes workloads and services, we can save a whole bunch of money on those network transfer costs. So, and this is one of those things that, is not always apparent until you kind of start looking at it in depth. And then you think, wait a minute, why would I have all this network cost? Oh yeah, if I redesign my topology a little bit, I can improve that by making sure that the services, that are more being communicated with are, located within the same zone, within the same region. And then we've got cost monitoring tools and right sizing your resource request. So these last two things here are what we're going to kind of focus on here for the remainder of this little presentation. These are key areas where Kubecost can help. So how does Kubecost help reduce spend? There are a number of different tools available in the Kubecost toolbox to help reduce your spend. First thing we're going to look at is real-time cost visibility. So one of the things you look at if you're looking at your cloud billing data and you want to understand, for example, what does a Kubernetes workload cost or what does a Kubernetes service cost? It's really difficult to get that information. Your cloud provider, your cloud service provider billing data is going to have those at a much higher level. Like I'm going to be able to see things like my VPC cost, gateway cost, virtual machine instance cost, things like that. But getting information out of that down to what does a Kubernetes workload cost running in a given namespace, that's a little more difficult for those cloud providers to do. That's one area that Kubecost does a really good job of helping reduce spend. And again, this is the kind of next bullet point there is the same thing. We can drill all the way down to the container level. So if I want to understand what is a deployment cost, what is a service cost, we can drill all the way down to the container level and give you that granular cost insight. We can also give you optimization insights based into those workloads. So I may have workloads that are under provisioned or that are over provisioned. So we can give you insight into those types of workloads. Typically, what we see is we can, with those with organizations we work with, we can typically help them save 30 to 50-ish% on infrastructure spend, sometimes a little bit more, depending on how they have those workloads provisioned. But there is almost always there's some savings that's available. We can also look at the efficiency of my cloud resources. So we can look at things like underused nodes and storage that's over provisioned. So what can I go remove from that cloud that my workloads are not going to miss, but that are also going to save me a couple of bucks in that cloud bill? We can do things like set alerts. So I can go and I can configure my workloads, to optimize their resource requirements. But I can also set alerts so that if an efficiency score drops below a certain figure, or if a cost goes over a certain figure, we can set up notifications to notify those users and teams that your efficiencies dropped or your costs have gone up. We can also give you recommendations for right sizing. So for optimizing container resource request, back when we were looking at the pod spec there, when we're talking about the differences between between resource requests and limits, Kubecost can give you optimized suggestions for those resource requests, again, with an eye towards saving some money for an over provisioned workloads. And then the last thing Kubecost can help you with is a multi-cluster unified view of the cost across all of your cloud environments. So we can offer, for example, if I have workloads deployed in AWS, Azure, GCP, I want to understand what the costs are across all of those environments, all of my workloads in one proverbial pane of glass. Kubecost can do that as well. So having said that, let's take a look at the UI. We're going to spend, I'm going to touch on just some highlights. I want to make sure we leave a little time at the end for some questions and such. So we're not going to go into a ton of detail on all of these things, but I do want to hit y'all with some highlights so you can kind of get a feel for how it is that Kubecost can help you with those, with saving some of that cloud cost. So the first thing we're going to look at here, this is my overview, this is my landing page. Most of the stuff that's on this page is going to be some trending information, some at a glance type information. But the key thing to notice here is this unified view of all of my resources. So in my little demo environment, I've got clusters in AWS, Azure, and GCP. I can keep track of all of those resources here in one UI. Now we're going to come down here to this monitoring section. This is probably where we're going to spend more time than some of the others. This is where we're going to start to see that really granular cost allocation. And this is where we can start to see, do I have workloads that are efficient or not? What we're looking at here is these are workloads broken down by namespaces. We're collecting up those cost metrics based on these Kubernetes, the types of metrics that the types of resources that Kubernetes workloads consume. So we're looking at these costs and they're based on CPU, GPU, memory storage, and network and load balancer costs for that workload. This cost that we're looking at here at the end, this total, that represents a cost for that namespace or for that workload across all of those environments. So this $21 and change represents the cost for me to run Kubecost across Azure, AWS, and GCP. So again, that unified view of all of my costs. There's also a bunch of different ways we can slice and dice this data. We're looking at namespaces. Namespaces are a really nice way to aggregate data. A lot of our customers are going to segregate workload boundaries on namespaces. And same thing in a multi-tenant environment, namespace also often is a very logical way to segregate resources. So we're going to default to namespaces here in this view, but we can also aggregate my data by any of these other types of Kubernetes objects or concepts. So this goes back to the idea of, is my cloud billing, my cloud service provider going to tell me what, for example, it costs to run my Loki headless application everywhere that it lives? No, but Kubecost can do that by virtue of this allocations view, which again goes back to the idea of granular cost allocation. The other kind of key metric that we see in this view, and I'm just going to go back up here. I like this little namespace view. It's really simple, is this efficiency score. So back to the idea of, are my workloads under provisioned? Are they over provisioned? Do I have opportunities where I can go save some money in my cloud workloads? This efficiency score is going to be the first sort of indicator of that. And what we see here is I've got some workloads that have a very low efficiency score, like this one at a little over 4.5 or a little under 4.5%. And then I've got ones like this, which are well over 100%. And the difference here is the workloads that look like this that have very low efficiency scores, these are typically over provisioned. So I provisioned a lot of resources that are not being consumed. Ones that look like this typically represent workloads that are under provisioned. So they're going to be in some danger of being out of memory evicted or CPU throttled. So this is kind of my first indication of, do I have workloads that I might want to go take a closer look at with regards to, I've got a really high efficiency score. These workloads may be in some danger. I've got a really low efficiency score. These workloads may need looking at in terms of they're probably costing me money. That's excess spend. The thing that kind of goes with this in this view, this idle figure represents a dollar amount that is directly associated with these inefficient workloads. So that idle figure here you can think of as being literally wasted cloud spend. This is money that I don't have to spend, but I am spending. So that's kind of this view. That's kind of the first step here then, this idea of, I want to get that really granular cost, visibility. I want to understand what my allocations look like in terms of my, very specific Kubernetes things, my workloads, my services, my deployments. And this is where I can start to see then, do I have workloads that need looking at in terms of efficiency? Once I see here that I've got some workloads that need some shoring up, then the next kind of step there is savings. And this is where we can start looking at avenues of actually saving some of that cloud spend based on some of the concepts and ideas that we've kind of already talked about. And I kind of like to look at this as a bottom-up type of exercise. But so I like to kind of use as the first stop as this right size container request. And this is kind of what we were talking about earlier. So I'm going to pick on this workload right here. And what we're looking at is we can see the request for this one. So I'm requesting a little over a gig of RAM. But this one is maximum usage. The maximum usage of that memory is only 15 megs. So that kind of gray cross-hatched area underneath down here, this represents those resources that this workload is wasting because it's requesting them and not consuming them. So Kubecost can give you a recommendation based on the actual usage figure there. We can do the same thing for memory and for CPU. Same idea. I'm requesting a lot more resources that are being consumed. If I go back and refactor these applications, this is a dollar amount that I can look at saving based on, making sure these workloads are a little bit more optimized. One thing that's kind of cool here in this view is earlier we talked about different environments, different ways of optimizing different environments. We can customize these recommendations based on environment. And this is kind of what I touched on earlier. In a production environment, these recommendations back here are going to be at 65% utilization of CPU and memory, or you can think of that as leaving 35% overhead in the cluster. If I want to look at optimizing my resources in a dev environment, then the recommendations that are given are going to be at 80% utilization. So again, that idea of different environments are going to require different types of optimizations. So kind of first stop here, let's go take a look at my Kubernetes workloads. How can I optimize these to make these more efficient so that we're not wasting resources? A lot of the other things here then are going to be things that, for example, persistent volumes. This is another good one. These are, you can see here, I've got my capacity. These are provisioned quite a bit larger than what's being consumed. And again, back to this idea of different profiles. So production development environments going to be a little bit different in terms of how I want to optimize them. But this is what we're looking at here is these things are provisioned, wildly over provisioned as far as capacity. Kubecost can tell you what's being used in terms of that persistent volume and a recommendation to set that capacity or to resize that volume with an associated dollar amount that can be saved. And then without going through all these, there's a couple other ones that I think are pretty cool. Abandoned workloads is a really nice one in the sense that this one's based on traffic. It's a little bit different. So if I set a traffic amount threshold and a time window, these are workloads that have not seen 1,000 bytes of traffic per second over the last week. And so in general, if a Kubernetes workload is not seeing network traffic, chances are it's not doing anything. So we see this very, very often, especially in development environments. Developers will go and spin up test workloads, and they're not always the best about cleaning up after themselves. They'll sometimes leave these resources running out there as little abandoned workloads. This gives you insight into those. We can click on this little drop down guy and we can see this is the cluster it's running in. This is the namespace. Here are the resources that are being consumed. And again, if I go and delete this abandoned workload, there are associated savings that come as part of that. So the idea is I work my way up, container request, I delete things that are not being used, I right size persistent volumes. If I have underutilized nodes that are basically looking at, we're looking at CPU and memory utilization here. In my example, all my nodes are actually, they're being pushed really, really hard. So I don't have any nodes in my environment that are underutilized. And you can see here the types of checks that we're looking at. So we're checking a bunch of different metrics to see, is this node being used as efficiently as it could? In my example, I can't move any of these nodes because all of these things would prevent that from happening. But again, a lot of times when we're working with customers, we will see that there are underutilized nodes in the environment that can be detached from the cluster, again, resulting in some forms of savings. So that's kind of part of it. So we can save some money. Now we've seen where's my money going? Where can I achieve some savings? The next part of that then is I got everything in place. I want to make sure that my teams that I'm working with are aware of what it is that they're spending. So I want to be able to send alerts based on certain things. There are a couple of different types that we can look at. We have ones that are triggered based on an event. So this one's going to be when a cost goes over a set budget limit based on any of these aggregation types. I give it a cost threshold. Once that threshold is gone over, then I want to send a notification, either a webhook or to an email distro. So the idea here is make these teams aware of the cost that's being incurred. And then when they're out of budget or going over a budget, let them know so they can be conscious of where that budget is. The other types of alerts that are built in here are what we call recurring updates. Those are going to be more of a daily, weekly, monthly report type of thing. So it's more time-based versus event-based. The couple of other kind of things that we've got here that go with this, there's one other piece that fits in here that goes with this, which is governance. There are 3 RBAC roles built in. So if we kind of put on, there's an administrator, an editor role, and a read-only role. So if we kind of put on that administrator hat, I can go create a budget. That budget can be for an application, for a team, for a service, whatever you want it to be. It can be based on any of these different types of cost metrics that we're collecting. It can be a weekly or a monthly budget. We'll give it a dollar amount here. And then we'll just say, I want that budget to be based on a namespace. So we'll use this Acme Fitness namespace. Now I can create an action based on that. I can create this trigger percentage. This is again to notify those teams. You're within 25% of your budget for the week, for the month. You've gone over your budget for the week, for the month. I want to trigger some actions based on what is occurring in the environment. And again, we can send those to email, to Slack, to Teams, to webhooks. But I can say, hey guys, you've gone over this. You're approaching your budget for the week, for the month. You've gone over your budget for the week, for the month. You need to go and do something about that. The last piece that goes with this, there are a couple other little tools that are built in. One is called Cost Predict. And this stuff is, for what it's worth, this is all out in our GitHub repo. I would encourage anybody who's not looked at it, there is a free version of Kubecost. So you can go grab this from our website. The tools I'm talking about are out in our public GitHub repo. This one in particular is called Cost Predict. And what Cost Predict does is you can point a manifest or a directory of manifests at it, and it will tell you what a workload costs before it is deployed. So we put that together with this governance capability, and then we can, the kind of rest of that workflow looks like this. Based on the outcome of Cost Predict, if a workload is going to exceed a budget, I can use an admission controller, something like Kubernetes, to do things like flag that for later review or even prevent that from being deployed. So part of this governance piece here is I can create a budget. I can notify those teams where they are with regards to progress, in that budget. But I can also put some teeth behind it as an administrator with some capabilities in terms of being able to disallow those workloads from being deployed or flagging them for later review. So that's kind of the quick tour of Kubecost here. Again, we've talked a little bit about some stuff in terms of tooling we can use to optimize both costs and resources in our public cloud. How do we establish a baseline? What do we kind of need to know going into all this? And then we've talked a little bit about how Kubecost as a tool can help you identify and track and those costs as well as achieve some sort of savings and then put some governance behind it. So I'm going to stop there. I think Joe was kind of keeping an eye on questions as they were coming up. So we can take a couple minutes here and field questions. I'll stop here. Joe, what?
What a great presentation, Mike. Thank you. And an awesome demo. Super insightful, really powerful information. We've got about 11 questions that have piled into the Q&A. Just a reminder for anybody in the audience that wants to ask a question, hit the Q&A button at the bottom of the screen and add yours to the list. So dive right in here. The first question is efficiency, and I assume efficiency in Kubecost. Is it based only on cost or also on resources? Cost control is nice for the cloud. How do you arrive at a cost for on-prem? So it sounds like there's maybe a couple parts to this question. I'm going to take a stab at answering the first part. When Kubecost talks about efficiency, it's really about an absence of waste, right? Or the amount of waste that you're able to get rid of. So ideally, what you want is to be requesting or reserving exactly the amount of resources that you need in the real world, in actual operation. Anything that you request or reserve above that could potentially be waste. Anything below that is risk. So I think, matching that that utilization to actual requested or reserved resources is what we talk about when we're talking about efficiency. And cost is kind of a byproduct of that, right? If you are very efficient in your utilization, then you don't have waste, which means that you're saving what otherwise would be wasted cost. Mike, correct me if I'm wrong, or feel free to add on to that statement about efficiency.
You're there. I'll pile on just a little bit. And one thing I didn't touch on is when we look at this efficiency score out here, this number is directly related to, it's the difference between the amount of resources requested and what's being consumed. So as the delta between resources requested and resources consumed grows, then that efficiency score is going to drop. But this is exactly where it comes from. And then the second part of that question, on-prem. So Kubecost, we get our baseline pricing for public cloud environments. We get our baseline pricing for those resources from the public on-demand API as a baseline. And then we can also integrate with your billing data. So we do some reconciliation there so we can account for things like savings plans, discounts, all that kind of good stuff. So that's how we give you accuracy in a public cloud. On-prem, it's a little bit different. In an on-prem environment, we use what we call custom CSV pricing. And what that is it's a spreadsheet that's going to detail the cost basis for your assets. So you would need to understand, what does my CPU cost, I've gone out and I've spent all this money on, racks of hardware. Here's my bulk total. What is my average cost for CPU, for memory, for GPU, for those resources? You put those in this CSV file, and then we can ingest that CSV file, and we will use that for costing in an on-prem environment. I hope that helps.
That's great. And yeah, and it gives you a lot of power, right? You can choose how to amortize those CapEx expenditures. You can weave in your own unique costs when it comes to literally powering those racks of equipment with electricity and all of the other things that can drive cost around an on-prem environment. Hope that answers your question. Next question is, what's the difference between VPA and autoscalers?
So VPA, so that's a good question. So without going into, and you could beat this up all day long, but basically, so the VPA is going to be the vertical pod autoscaler is going to give those workloads resources based on what they're consuming. So in this example, we'll say this guy here is consuming, 25 megs of RAM. The VPA is going to say, let's give based on historical, at 25 megs of RAM, this application runs great. At 10 megs of RAM, it gets OOM killed. So the VPA will say, let's set the resources. It'll give you a baseline for that resource for that workload. Autoscalers in those public clouds are going to be a little bit different in the sense that Carpenter and Autopilot and they have slightly different mechanisms of behavior. But for example, one of the things Carpenter does is it can look at all the resources that you need for a given, so I'm going to go out, I've got all these Kubernetes workloads running, and as a whole, I need X amount of memory, X amount of CPU for those workloads. What Carpenter will do is it will go out and it will look at AWS node sizing, and it will go and spin up nodes that are appropriately sized for that group of resource requests. So the VPA is looking very much at pods and what the resources a pod needs, whereas those autoscaler tools in the public clouds are looking more at how do I scale up my clusters, but then do it in a little bit. For example, Carpenter tends to be a little quicker on the draw than the built-in Kubernetes autoscaler. And so that's what folks look for in that is those public cloud autoscalers typically have a little bit more capabilities than the built-in Kubernetes ones, and they typically react a little faster. They can also be customized. Again, Carpenter be customized to say only recommend or only use these specific AWS instances. So you've got a little bit more power there with one of those cluster autoscaler tools versus the VPA.
Next question from the same question asking individual. How does VPA work in conjunction with resource requests or capacity allocation? Can VPA decrease the resource allocation below what was requested?
It can. So part of that VPA spec, there is a min request and a max request. And so you can kind of put those guardrails, if you will, around there. And that's part of that VPA spec. You can literally say, here's the minimum amount of resources, here's the maximum. So it can go down to that minimum, but it won't drop it below, whatever you've configured there.
That's great. Next question. Do you see large enterprises using VPA recommenders or Goldilocks in production? Are these still limited to the retention period of Prometheus? And what about for financial service firms that might have workloads that need to adjust based on factors like seasonality?
Yeah, good questions. So and keep me straight here, Joe, because I'm going to forget
Will do.
the
So the
second.
first one was, do large enterprises use things like Goldilocks in production?
They do. And what I'm shocked about is not no, when we talk about in production, they're not going to necessarily run that in a prod environment, but but a lot of organizations do use tooling like that to get that baseline for those resource needs. So in my dev or test or staging environment, this is typically where we're going to see something like Goldilocks being run. It's just going to give you some sensible baselines for those applications. I don't know about production really. I personally would shy away from it, but we do see a lot of pretty large enterprises leveraging a lot of open source tooling these days, which personally I think is pretty cool. But yeah, Goldilocks normally you're going to see in more of a staging or dev test type of environment. And the
Makes
second
sense.
part of that, Joe?
Are tools like Goldilocks limited to the retention period of Prometheus?
Yeah, everything is. Prometheus does what Prometheus is going to do. So you are to some extent limited there. One of the ways that, for example, and I can't speak specifically to other tooling, but one of the ways that Kubecost handles that is we configure Prometheus for a retention period. And then once that period, and typically it's 90 days, once that 90 days is up and we've stored that 9 days worth of data in Prometheus, we'll roll that off to like S3 or object storage, something longer term. But yeah, in general, you're going to be limited to that Prometheus storage limitation unless you have configuration otherwise to roll it off somewhere else.
That makes
I think
sense.
there was I think there's a third part to that.
There was. The third part was how do tools that handle, VPA recommendations, things like Goldilocks or Carpenter, um, how do they account for like seasonality and spikiness in app utilization and resource requirements?
Yeah, that's a good question. So as far as those particular tools, I would actually have to go dig into some documentation. But what I can talk about is how we do it. So when we look at our recommendations, I can choose a time window that's appropriate. So for example, if I have a workload that runs once a month, quarterly, I can stretch this time window out to make sure I capture that workload, especially if you've got workloads that a lot of times there's a startup, and that when that workload starts up, it's going to consume a lot more resources. And once it settles down, I can then put my sizing window out there to make sure that I capture that workload when it starts up. So I capture that startup period, and then as that workload runs throughout its lifespan, I can use this little time slider here to make sure I capture that in detail. As far as like how Carpenter and Goldilocks do that, off the top of my head, I'm not really sure. I'm gonna have to go dig into some docs, but I would imagine it's similar-ish type of mechanism.
Great. I've got a question here. Individual thinks that maybe CPU pressure can create, CPU throttling and asks, does Kubernetes perform pod eviction because of CPU pressure?
So typically what we see, actually, let me come back up here. I'll show you. We do have some tooling built in. I'll just grab one of these guys. Let me see. I don't know if this is a good. This is not a good. Oh, it is. Somewhat of a good hit. So as far as what's tooling built in, so typically what we see is when workloads get evicted, it's going to be for memory consumption. When workloads we see two things, and this is what Kubecost kind of looks at. For when memory utilization goes too high, we often, your workloads are in danger of being OOM evicted or OOM killed. When we hit CPU limits, usually that workload will be CPU throttled. So we've hit our limit. We're not going to give that workload any more CPU. But typically we're not going to go kill that workload. Usually that's a memory thing.
Excellent. Next question from the same question asker here. Does Kubecost only recommend, or can it automatically take actions for right sizing by adjusting requests and limits? And while you're navigating to that area, yeah, we can do some automated actions, things like cluster turn down and some node right sizing. So I'll let Mike answer here with some visual aids.
Yeah. And so basically and we can. So some of those things that we looked at earlier can be automated. This is a component we call actions, and this requires a cluster controller to be enabled. I do not have it enabled in my environment, but some of those activities that we looked at earlier that will result in some cost savings can be automated. The ones we see most folks using are this request sizing and then the cluster and namespace turn down ones. Request sizing is exactly that. I want to make sure that my CPU and RAM are kind of, requested appropriately. And then the cluster turn down and namespace turn down, a lot of times, again, dev environments, we'll see organizations will turn down clusters or namespaces over a weekend when they're not being used by those dev teams. Those are, I would say, probably the three most popular ones are going to be the request sizing and then the cluster and namespace turn down. But yeah, this can all be automated using Kubecost actions with enabling that cluster controller. And as I touched on earlier, all this stuff's out in our GitHub repo. So if y'all want to give this a go, cluster controllers out there, grab free version of Kubecost, spin that cluster controller up, and see what it does, see how it behaves.
That's great. There's a quick follow-on question from Debashish that asked this question, which is, will it create application disruptions or Kubecost will spin up a temp pod before restarting pods? So I think the question is around this right-sizing capability and automated actions if there's going to be disruptions to the application because pods are like, spun down and up.
Yeah. So there are limitations to this, and again, this is in our documentation, but effectively, what we look for here is when we look, especially with I can't talk, especially with regards to request sizing. That workload needs to be part of a controlled workload. So for example, I need a minimum amount of replicas, or it needs to be part of a daemon set. This makes sure that as I am as we're kind of refactoring, resizing those apps, there's still a minimum number of replicas that are still running. So this doesn't work for things like if I've got just single individual pods, it will not work for those. There are, and again, I think there's a couple limitations. It's changed recently. I'd have to go look at some docs, but in general, it needs to be a controlled workload, and it's for exactly that reason. If we want to make sure as we're rescaling a workload that there are pods that are part of that deployment or that replica set that can then take that load while the individual pods are being rescaled.
Excellent. Next question. Can we filter our non-application namespaces in Kubecost? As a central platform team, we want our tenants to only view their namespaces. It's a great question. And the answer is absolutely. And yeah, Mike's going to show you how here.
Yeah, so there's typically what we look at here is this. So if we have in a multi-tenant environment, I want those tenants to only be able to see resources that belong to them. So for example, their own namespace. We can use, I touched on our RBAC earlier, so we do have RBAC built in. We can also use what we call filters for this area right here. And so we can use RBAC to assign a user as a read-only user, an administrator, an editor. We can then use that filter to allow them to only view the resources that they're allowed to view. And that view can be broken down on any of these lines here. So namespace is a perfect example. I want to log in. I only want these people to be able to see their namespace, or flip side of that, if they're the product owner or a service owner, I only want them to be able to see their product or service. Same thing. We can limit that view based on any of these constructs.
Yeah, it's a great question. And if you're a centralized team, like you're a platform team, you want visibility to all of the applications, but you don't want to have all of the noise in there for things that are, non-applications or just don't need to be monitored. Then you can filter those out using these same namespace filters to only see the namespaces that are meaningful to you and your team. Next question: does Kubecost try to limit CPU throttling?
No. So Kubecost, we look specifically at resource requests, and that's all. We do not do anything with limits whatsoever. We do have a partner organization that oftentimes when folks want to kind of understand better how to enforce those limits or how to work with limits, Stormforge, they have pretty good tooling that is specifically designed for that. But Kubecost, we look purely at request. We don't do anything with limits.
Great. Next question. Can we view a time series of CPU or memory utilization usage divided by requests in Kubecost, or is the recommendation for tenants to view that in something like Grafana?
Yeah, so it's a good question. So there is some measure of graphing here in terms of let's see here, in terms of like resources over time. But each one of these, so this is an example of that. This is what's built in. But what we can do is if I drill down into, I'm just going to drill all the way down in one of these. We're looking at, so we drilled down through namespaces to controllers. Now we're looking at pods. Now we're looking at containers. All of these, we do have Grafana built in. So if I want to drill all the way down and open these up in Grafana, I can do that. We also have a Grafana JSON data source that can be used. So you can plug all this stuff into Grafana and just graph away to your heart's content.
Great. And two last questions here. How does Kubecost set a baseline, or do you use any EMA to set a baseline? And I'm assuming the question relates to like, when I start using Kubecost, how does Kubecost establish a baseline of utilization and cost and things like that so that it can then know, the right thing to do?
Yeah, so for what it's worth, 9 times out of 10, 9.5 times out of 10, when companies come to Kubecost, they've already seen this problem, and where we've got these resources that are wildly over provisioned. And so what we look at here is kind of an after the fact sort of thing in terms of, okay, let's go rein that in. There is a little bit of tooling here. I'm going to come back here to this allocations view. There is one thing that's kind of built in. We can look at this cost forecast. This does require some data to be stored. So this requires 100 days worth of data, which I don't think I've got yet in my demo environment. But after about 100 days of data, we can give you a projected spend with some measure of confidence. So some of it is, we can give you some projections based on historical data, and then some of it is once Kubecost is up and running, we can use. In fact, usually what we tell teams is the questions like, how do we size Kubecost? The answer is almost always spin it up, let it run for a few days, see what resources are being consumed, and then size it from there. So it's almost, it's oftentimes a little bit of an after the fact or a wait and see type of thing. But what's built in is this projected spend capability. I think this would probably be, in terms of a projected sort of thing, a forecasting thing. This would probably be the closest sort of tooling that we would have.
That's great. And when a customer first wires up Kubecost to their cloud service providers, reporting data on cost and utilization, they get all of that data, right? As much of it as is available. So the baseline essentially becomes the reality pre-Kubecost.
Yeah, you got it. And so when we do the whoops, wrong one, cloud cost. When we do that, will we integrate with that cloud, with that billing provider from that cloud? We're going to pull in everything that we can see in your billing data, Kubernetes and otherwise. So this is where we can start to look at, resource utilization outside of Kubernetes. So yeah, we can pull in all that stuff. That's kind of what this, as we do that cloud integration part, you'll be able to see everything that's in that cloud. So you will have some metrics and some information to work with. That's also non-Kubernetes stuff. So you can get that whole picture of Kubernetes and non-Kubernetes workloads.
That's great. A follow-on question from that one was, what's the projection or the forecasting algorithm? And I'm not sure if we have a ton of information on how we calculate that available in our documentation, or maybe I'm incorrect and we've got lots.
We really don't. It's really not it's not documented at all. And from when I've spoken to our product management, that's kind of one of those things that they're kind of keeping in their back pocket, a little bit of a secret sauce sort of thing. So yeah, I really I don't have any additional detail beyond that.
I know the terms get thrown around a lot, especially these days, but we do utilize some AI and machine learning when it comes to forecasting. And so that may be responsible for us being a little cagey about the secret sauce there, is that it is some machine learning that looks at your individual reality, right? To make some forward-looking projections based on what it knows. And the
That's exactly.
last question we've got here is, how do you define and quantify efficiency in Kubecost?
Okay. So there are a couple different ways. We define efficiency across a couple of different metrics here. First one, I'm going to mouse over this. One measure of efficiency is what we call workload idle. So this is kind of what we were looking at earlier. These are resources that are requested but are not being used by any Kubernetes workloads. So these are requested resources, but Kubernetes is not using them. They're effectively wasted resources. The other type of idle that we look at is called infrastructure idle. And this is hardware resources that are not being used or requested by any Kubernetes workloads. So these two things together kind of combine to create this overall efficiency view. And there are two flavors of efficiency. This cluster efficiency is comprised of both workload and infrastructure idle. When we look at allocation, this efficiency, this is based purely on that difference between, CPU and memory, purely the difference between resources requested, resources consumed. So there's two or three different ways you can look at efficiency. This one's based on Kubernetes workloads. This cluster efficiency is a combination of that and infrastructure idle, if you will, or inefficiency.